According to the National Electrical Code, it is generally not acceptable to frame directly against the sides of an existing breaker panel. The NEC mandates specific clearances around electrical panels to ensure safe operation, maintenance, and accessibility. A minimum clearance of 30 inches or 762 millimeters in width is required in front of the electrical panel. This space must be clear and unobstructed to allow a qualified electrician to safely work on the panel. There must be at least 36 inches or 914 millimeters of clear space extending from the front of the enclosure. This working space is measured from the front of the enclosure and should be clear of any obstructions, such as doors that might swing into the space. The minimum headroom clearance for service equipment, switchboards, panel boards, or motor control centers must be 6 feet 6 inches or 1.98 meters. This is measured from the grate floor or platform. If the equipment exceeds this height, the headroom clearance must be equal to the height of the equipment. The NEC also addresses the required width of the working space in front of electrical equipment. The working space needs to be either 30 inches or 762 millimeters wide, or the width of the equipment, whichever is greater. This ensures sufficient lateral movement for personnel working on the energized equipment. The depth of the working space in front of electrical equipment varies based on voltage levels and conditions. For example, condition 1 exists where there are exposed energized parts on one side and grounded parts on the other side, or where grounded parts are on both sides. Condition 2 exists where there are exposed energized parts on one side and insulated parts on the other side. Condition 3 exists where there are exposed energized parts on both sides. For voltages to ground of 0 to 150 volts, the minimum clear working space depth is 3 feet or 914 millimeters for condition 1, 3 feet or 914 millimeters for condition 2, and 3 feet or 914 millimeters for condition 3. For voltages to ground of 151 to 600 volts, the minimum clear working space depth is 3 feet or 914 millimeters for condition 1, 3 feet 6 inches or 1.7 meters for condition 2, and 4 feet or 1.22 meters for condition 3. For voltages to ground of 601 to 2500 volts, the minimum clear working space depth is 4 feet or 1.22 meters for condition 1, 4 feet 6 inches or 1.37 meters for condition 2, and 5 feet or 1.52 meters for condition 3. For voltages to ground of 2501 to 9000 volts, the minimum clear working space depth is 5 feet or 1.52 meters for condition 1, 6 feet or 1.83 meters for condition 2, and 9 feet or 2.74 meters for condition 3. For voltages to ground of 9001 to 25,000 volts, the minimum clear working space depth is 6 feet or 1.83 meters for condition 1, 8 feet or 2.44 meters for condition 2, and 10 feet or 3.5 meters for condition 3. For voltages to ground of 25,001 to 75,000 volts, the minimum clear working space depth is 8 feet or 2.44 meters for condition 1, 10 feet or 3.5 meters for condition 2, and 12 feet or 3.66 meters for condition 3. While the NEC specifies minimum clearances, local codes may have more stringent requirements. Always check with your local building department or electrical inspector to confirm specific regulations in your area. It is also important to ensure that the panel remains accessible after framing. The panel door must be able to open fully, and there should be no obstructions preventing access to the breakers and wiring inside the panel. Sufficient lighting should be provided in the vicinity of the electrical panel to ensure safe working conditions. The NEC requires that lighting be provided for all working spaces above service equipment, switchboards, panel boards, or motor control centers installed indoors. Additionally, the working space must be kept clear of obstructions that could hinder access to the electrical panel. This includes stored materials, equipment, or other items that could impede movement or create a safety hazard. Any penetrations of fire-rated walls or ceilings must be properly sealed to maintain the fire resistance rating. This is especially important in basements, where fire separation between different areas may be required. Firstly, consider the panel's location. If possible, relocate the panel to a more accessible location before framing the walls. This can eliminate the need to work around the panel and ensure compliance with clearance requirements. Secondly, if relocation is not feasible, carefully plan the framing to provide the required clearances around the panel. Use precise measurements and ensure that the framing does not encroach on the working space. Thirdly, consult with a qualified electrician. An electrician can provide valuable guidance on NEC requirements and best practices for framing around electrical panels. They can also identify any potential safety hazards and recommend solutions. Fourthly, clearly label the electrical panel and its circuits. This will help prevent accidental contact with live wires and ensure that the correct breakers are turned off during maintenance or repairs. Fifthly, use appropriate materials. When framing around electrical panels, use fire-resistant materials such as fire-rated lumber or drywall. This will help protect the panel from fire damage and prevent the spread of flames. Sixthly, consider the panel's ventilation. Electrical panels generate heat, so it's important to ensure adequate ventilation. Avoid blocking ventilation openings or enclosing the panel in a way that restricts airflow. Seventhly, install a barrier. If necessary, install a physical barrier between the framing and the electrical panel. This can help prevent accidental contact with live wires and provide additional protection for the panel. Eighthly, inspect your work. After framing the walls, carefully inspect your work to ensure that all clearances are met and that the panel remains accessible. Make any necessary adjustments before proceeding with other construction activities. Ninthly, remember that working with electricity can be dangerous. If you are not comfortable working around electrical panels, hire a qualified electrician to perform the work. Attempting to work on electrical panels without proper training and experience can result in serious injury or death. Tenthly, consider future maintenance. When framing around electrical panels, think about future maintenance and repairs. Ensure that there is enough space to remove the panel cover and access the wiring inside the panel. The NEC provides specific guidelines for the protection of electrical equipment from physical damage. These guidelines are intended to prevent damage to electrical panels, wiring, and other components that could result in safety hazards. The NEC requires that electrical equipment be protected from physical damage by suitable enclosures, barriers, or other means. The type of protection required depends on the location and environment in which the equipment is installed. In areas where electrical equipment is exposed to physical damage, such as garages or workshops, the NEC requires the use of enclosures that are specifically designed to protect against impact, abrasion, and other hazards. These enclosures are typically made of metal or other durable materials and are designed to withstand the forces that could damage the equipment inside. The NEC also addresses the protection of electrical wiring from physical damage. Wiring that is exposed to physical damage must be protected by conduit, raceways, or other approved methods. This helps to prevent damage to the insulation and conductors, which could result in short circuits, electrical fires, or other hazards. In addition to protecting electrical equipment from physical damage, the NEC also requires that it be installed in a manner that minimizes the risk of damage. This includes avoiding locations where the equipment is likely to be struck by vehicles exposed to moisture or subjected to other hazards. The NEC also specifies the types of materials that can be used for enclosures and other protective measures. These materials must be resistant to corrosion, fire, and other environmental factors that could compromise their effectiveness. It is important to note that the NEC is a minimum standard for electrical safety. Local codes may have more stringent requirements for the protection of electrical equipment from physical damage. Always check with your local building department or electrical inspector to confirm specific regulations in your area. By following the NEC guidelines and local codes, you can help to ensure that the electrical equipment is protected from physical damage and that the electrical system is safe and reliable.